Hello, I'm Jason Rader, and welcome to today's Insight Live, the show where we get a bunch of smart guys together and talk about topical topics related to the technology and computer industry. Today, we're continuing our conversation related to expanding your horizons, growing your business with Intelligent Edge. And if you recall, we have Andy and Amal with us from our previous episode, and we've added Mike to the game today as we're talking about specific use cases, specifically computer vision. So why don't we take a second to remind everybody who you guys are and what you do here at Insight. Andy, why don't you kick off?
Hi, I'm a principal architect with a data center focus and infrastructure background based in Dallas.
Perfect. Mike?
I'm Mike Griffin. I'm Chief Data Scientist for Insight.
And last but not the least, Amol. My name is Amol Asgaonkar. I lead the Intelligent Edge strategy for Insight.
Fantastic. So I'm excited about today. Sorry, we had to do our intros, and now I can start waving my hands a lot more. So if you recall from our last, or if you don't even, we talked a lot about Intelligent Edge and kind of different broad different ways that we can leverage it from a business perspective. And one of the use cases that we got a little bit into was computer vision. And, that's a really interesting topic. And we all kind of talked about after the show that we want to talk more about that one. So we got Mike on here, and I'd like to kind of kick off for folks who don't recall or weren't there. Let's talk about what we mean when we say computer vision, Mike.
Yeah, computer vision is kind of the first step in intelligent applications. I like to think that we develop computer vision powered or computer vision enabled applications. So you can't really do too much with computer vision. Computer vision models will say identify objects in an image or a video stream, but what do you do with that information? That's where the application on top of that comes into play, where we can take that information and make actionable decisions out of it.
I love that. And so that kind of corrects the way that I'm thinking about it as well, because I think of computer vision as its own thing, but actually it's a component that enables those edge applications is a better way to think about it.
Yeah,
that's better.
As a data scientist, I'd love to think that everything revolves around me, but what we do...
Wait, it's not me?
What we do as data scientists is just a small part of intelligent edge applications. And we'll talk more about that, I'm sure. Andrew and Amal will certainly fill us in on that.
Yeah, and they're the center of everything in their world as well. So I think we're all going to be okay. So as we kind of add on to that, let's talk about the different components, because we all kind of have that different, the data science perspective, the development perspective, the infrastructure perspective, security perspective, all of those things. Let's talk about those components. If we were going to leverage an application that computer vision was a main component of, let's talk about those components individually. Amal, why don't you kick off with kind of how you would start thinking about this?
Sure. So when I think about computer vision, and if I'm thinking about building an application where computer vision is part of, the first one is collecting data, right? Identifying the business use case, like we spoke about in our previous session, understanding the business use case is key. I'm taking a step ahead now. We've identified what the business use case is, and we've identified that computer vision would be critical to solve that business need. Once we have that, I think the next step is collecting the right data. And when I say right data, is essentially making sure that the data is clean. And I'm pretty sure Mike will give you details about why that's important. But collecting that data, so having the right images, annotating that data, and then handing it over to the real smart guys like Mike, who can then do the magic of building the model and then give it back to us so they can operationalize it, right? So collection of the data, then building the model, testing the model, validating, verifying in different conditions as well, and collecting data in different conditions. And when I say conditions, lighting conditions, other environmental conditions that will affect how we see that certain piece, object, or environment, right? That really changes how that model will work. And so collecting all of that data, building the model, validating the model in different scenarios again. And once you are comfortable with what we are seeing, now comes the operationalization of that. So where do we run that model? Do we run that in the cloud? Do we run that at the edge? Do we run it in both places? Maybe a smaller model at the edge, a full-fledged model in the cloud, right? So there are a lot of pieces that need to happen. Now, that is, I just talked about one iteration. Now comes the second iteration where, okay, this is working for a couple of weeks, a month, or 2 months now. Data has changed, environmental conditions have changed, and now I have to build or retrain the model, and I have version 2. What do I do with version 2? How do I make sure that version 1 is deployed? Now version 2 is here. How do I deploy that? Test it while version 1 is still running, right? I don't want to disrupt the business, so I want to make sure these can run parallelly. Once I'm comfortable with it and I say, yeah, version 2 is better, now I can have better outcomes. How do I get rid of version 1 and make version 2? And then the cycle continues, right? So that is where we talk about MLOps, just like DevOps. I think we covered some part of it in our previous session, but it is key to make sure it goes to production and doesn't remain a POC. I'm pretty sure Andy and Mike have a lot to add on, but just at a high level, that is how I see different components of a solution.
If I can just interrupt a bit, because you did bring up a fantastic point that we always talk about, that we probably should have talked about before this, is that business case. Let's talk about some business cases first, and then I think, because then as we talk about it, we'll build it, and people will be able to kind of recognize why we're building or doing the things that we're doing. Thanks, Amal. So, what are some business cases from a computer vision perspective? Andy, I know you've talked a little bit about this before.
So I've been dealing with a lot of retail customers, and retail is kind of the next frontier for some of this. So Amal talked about building the business case and then collecting the data. A lot of our retail customers have the data and are trying to extract value out of it. It's a little bit
Fair
of a
enough.
chicken and egg issue. So a lot of them are trying to figure out how to do heat map tracking in their locations to figure out where to put Snickers bars or to where to move the milk or the eggs. I mean, it's that old school. Anybody that's been in a grocery store knows that the eggs and the milk are in the back of the grocery store to get you to pass everything else. Well, they're starting to figure out the other way of doing that is with AI, is predicting how people move through your stores and putting things in there. So computer vision's a big deal, has a ton of ethical issues that we'll talk about some other time.
We should.
People tracking in and out of doors and traffic mapping and retail is a big one. I mean, we see them across a ton of different industries, but those are some that I'm chasing with my clients right now.
Yeah. And Mike, so from your perspective, I think, especially as a data scientist, there's probably some use cases that are standard and probably some stuff that's maybe you think is probably coming on that as well.
Yeah, absolutely. And I think one of the things that's becoming more apparent is that computer vision powered applications need to understand context. And I had an interesting incident happen to me last week that upon reflection really illustrated a lot of the things that clients are asking of us now. They're not just asking for object identification, counting people. They want to know more about what's going to happen in their system, in the, say their factory floor, their clinical setting, or in a retail environment. And so I was running an errand the other night, and I was exiting a parking lot. And it was dark. This is in Massachusetts, and so I was exiting a parking lot. And there was a Dunkin' Donuts on my left, and this car entered the parking lot about 50 yards in front of me and parked to my right. And so that's the visual information right there. But on top of that, I knew that this person, the only reason this person was parking there is because they need to go to Dunkin' Donuts. And I knew that there was a person in the car, which a computer vision application might not know, right? So how do you actually overlay context into this situation? And I also knew that there was an SUV parked between me and the car, so I couldn't see this person exit the vehicle. But I knew that I was about 50 yards away, and probably by the time he got out of the car, we would kind of be at the same point at the same time. So all this processing went on in my head, just like everybody else does when they drive, sort of subconsciously. And it illustrated to me, oh, and by the way, we did meet at the exact same point at the exact same time. But I knew it was going to happen, so I had my foot over the brake, and everybody was safe and fine, and he was able to go get his donkeys. But
I think you need to talk to Elon Musk. I think he needs you.
Well, that's a really good point, because there's a huge industry around developing applications to make automated driving safe. But there are an infinite variety of situations that are context specific. In this case, there was a fast food joint in the middle of a parking lot, and a vehicle that could only be interested in going to that parking lot, and that vehicle turned into a person. So there was a lot of really interesting stuff going on there that illustrates, I think, exactly the kind of things that our clients are asking of us. And I can give some real examples as opposed to theoretical examples.
Well, and I will play the infrastructure card here, because what you're talking about, Mike, is tons of different data points, right? It's more than just computer vision. It's GPS data. It's maybe audio data. It's positional, accelerometer data. And so you look at those self-driving car applications, and there's a ton of sensors, a ton of data points, and then more importantly, there's a ton of processing that needs to be done in low latency on board that car or on board that device. And so I'm going to play the infrastructure card. That's the cool part about computer vision, is we need a fair amount of horsepower in a tight, compact package to be able to allow you to do all that cool software,
and
right?
I'll give you another example to reinforce that, is that what I was going through in my head was basically a scenario analysis or simulation of my system. That's incredibly compute intensive on top of the vision that you need, the computer vision applications that you need. So there's, I think, an incredible need and a growing and probably never-ending need for compute power at the edge. So if you're in the hardware business, you're in. Don't change your job. Just stay right where you are.
But I need you, Mike, to help me justify it. Right?
I think to build off of Amal's earlier point, I mean, in your example, Mike, you basically trained against a certain data set, and now there's some derived learning that's happened. How does that get from you, if we're talking about an application, back up to help the other applications? That's an infrastructure question. That's how we leverage that data itself, what we've learned, and how we train the next and get those generations of learning that takes place.
Exactly, and that's kind of what I was thinking. So whenever we're exposed to some kind of scary incident, we tend to reflect on it, right? And then, how could we prevent that from happening in the future? Well, nothing really bad happened, but as a data scientist, I'm thinking, well, how could I write an application that would help other drivers avoid that situation? And all these elements started to come into play that made it really complex, but not impossible. There's, it's a little physics application. I know my current velocity, I know the current approximate distance to that car, and how long it's going to take that person to get out of the car, things like that. So but it needs to be coded. And I think it's important to understand, like, if you're a client and you need a computer vision powered application, you need to understand that it's not just a vision application. There's a lot you're going to need and you're going to want to make this realize your ROI, your return on your investment.
Because I think at the end of the day, you want something that you can take action on, right? We don't want to run an application that, great to look at, but I'm not going to stare at it. Like, I want to do something when you give me that information, right?
Exactly.
And I want to be optimal in that efficient in that whole process. So, to give you another example, especially in manufacturing these days, anomaly detection and all of those, we've heard of those use cases, right? But I was in a manufacturing facility where they were making their product, which was injection molded, right? So two molds used to come together, and you inject material, and then it cools down. Like, hot material comes in, it cools down, comes out. And now once it's done, there are issues with it sometimes where the molding didn't happen, the cavity had some debris in it already, so it didn't look right. But you don't want that operator to put his hand in the middle, try and break it off, because if the machine doesn't understand and it closes back again, it's going to be one of those Tom and Jerry cartoons. So that, some of those use cases are so, from a safety point of view, they are so important. So it's not just about actionable insights for humans, it's actually actionable insights for other applications. So the other application could take the inferences that are coming out of that model and say, well, I can see a human whose hand is stuck in this whole thing, right? Or is putting his hand there. And so it sends action back to the PLC and says, shut down this hydraulic press so that, and turn on a light, right? So it's not just that the humans will take action. I think these are, I look at these as Lego blocks, where one Lego block can be put on the other Lego block and then another Lego block, and then those whole chain of events can happen. And that is where I think the operationalization of these technologies is important, and how we build these applications. Because if we build these applications as monolithic applications where nothing goes out and only, then we are not really providing the best benefit back to the customer. So they have to be extensible, and they have to follow certain standards. Like if you open up a protocol and you use standard protocols and say, okay, I'm going to expose this data stream securely this way. If anybody's interested, this is how you use that data stream. So every time we build any AI application, computer vision application, anything, we have to think about those future down the line use cases, and not just what are we solving right now for the customer. That is how I'm thinking at this. Otherwise, we try and paint ourselves in a corner, and then when there's another use case, we're like, oh wait, I have to re-architect the entire thing because of this one new requirement.
Yeah.
When you bring up an interesting point, Amal, you guys are talking about making actionable insights quickly, and again, the infrastructure guy in me hears the word latency 6 times.
Yeah.
Because we built AI in the cloud. That's awesome. For like my example of heat map tracking or people counting, I don't necessarily need to take action on that in real time. I can take action on it a few hours later, a day later. But in your example with manufacturing, or Mike's example with self-driving anything, we've got seconds at most to be able to make decisions on those kind of situations. And so it's that building that substrate too, so that it's an efficient architecture, both software and hardware, so that we're not introducing tons of latency, sending data all over the planet, that kind of thing.
No, absolutely. And you're on point with the infrastructure. If we don't have the right infrastructure for the right use case, and a little bit of buffer, because like I said, it needs to be a little bit extensible, then this whole idea of computer vision will just fall off. Because if it takes seconds for those images to go up, now even in the cloud, if it's microseconds and I'm getting my inferences, there's no point, because it took 4 seconds for that to come back and let me know what happened. So it really needs to happen at the edge, and we can send all of that data after the fact, or in parallel to the cloud for historical purposes, for auditing, for compliance, what have you. But the actionable insights that have to happen at the edge, and infrastructure is a very big piece. And that drives security as well, right? So I know Jason can talk for hours around security, and I think in one of the following sessions we should address security. But I think you're so right in terms of having the right infrastructure in place. And when we say infrastructure, I believe, Andy, you're talking about not just compute, but it's networking, it's cabling, it's switches, routers, everything that goes with it, right?
Yep, but it's not in a vacuum, right? I need the software layers that sit right above the hardware to also be extensible, to also be industry standard, right? That's where we see a lot of container architectures and things like that you guys consume. And the part that brings this to mind is, we were talking about this before the recording, but there's a neat article that NASA is talking about the compute that they've installed up in the space station to be able to monitor the astronauts and things like that. And they initially were doing that across the link, but they talk about how it's a lossy link and it's got horrible latency. And so they've been able to go from daily monitoring of astronauts to hourly or sub-hourly monitoring of their health and stuff, because there's a bunch of compute on the space station, totally the intelligent edge in a different way.
And in those use cases, I don't think oops is an option, right? Stuff has to work.
And I think both of you are talking about, in data science speak, modeling systems, and we're all of our clients are asking us to model, once we have a model, to enhance that model. How do we build more and more knowledge about what we know about that model into our model, such that we can optimize, we can make better decisions? And that's going to go on and on and on. That's a never-ending process. And so the compute demands at the edge are just going to go straight up for a long, long time.
Yeah, Moore's law in a different context, right?
Sort of. Yeah, exactly. Yeah. No, I agree. I think, and that's the thing that I was thinking was interesting, because I'm kind of, musing at the fact we've got a security and infrastructure data scientists develop all in the same room, right? Or all kind of. But there's innovation that takes place at all of these levels. So it's more than just the data science innovations. It's more than the infrastructure innovations. It's interesting on how, when you get the right thought process into how you develop and how all of this stuff comes together, because easily you could develop sloppily and just increase the bandwidth. You know what I'm saying? So there's all of this, but when you leverage what you can out of each of these things, I think that's when you're going to that transformative kind of approach to, interesting problems that we could never solve before. I mean, that's what I'm used about from a big data perspective is, when back in from a security perspective, there was a time where I worked at a very large organization where it took us 26 hours to process all of the logs, which means we were never going to catch somebody, potentially, if we had to go through all of them. We were always going to be a day behind. Literally, after a platform update and all the applications were updated, in less than a year's time, we could do it in 6 minutes. So that's like an exponential way to tackle a number of significant problems. But it wasn't one thing. It wasn't just because we could process faster. It was because everything had to come together to make that happen. And that was a decade ago. So now, as we move forward, especially with the things in like private 5G and other ways that we can get, when we do need to transmit, we've got that infrastructure in place. The way that we're using microservices and those types of things to develop, and the way that we're able to model at the edge and then, update as quickly as we can thanks to that bandwidth. I mean, that now we're like talking next generation stuff.
Yeah, I think.
Well, Amal brought up a great point too about scale. Just a little plug for Amal's comment is, all of this is fine and dandy, and then let's do it at scale, right?
In the lab,
and that trains the software, the data science, all that. Like a small model, Mike, is way different to work with than a massive model, right?
And I think you're on point, Jason. From a measurement point of view, how do you measure, right? So most of the times, in other use cases, you can measure by, like you said, it took X amount of time to process this data. Now it takes Y, right? And Y is less than X. But I just had to say that. But when
I saw you.
But when we are talking about computer vision, and in computer vision, most of the times people will say, I can process X frames per second. That literally means nothing to the business owner. But if I start talking about outcomes per second, like, if this is the outcome is I have to make sure that these many products have been detected or not detected per second. If my assembly lines is, fast, where I'm moving 1,000 bottles per second, great. Now, if those outcomes per second matches my processing of the product itself, I think that is a much better measurement than saying, well, I don't know about your business, but my system can do 60 frames per second. In one frame, I can do 10 bottles. Like, that's still 600, dude. What about the 400 that you missed? So I think we should start changing how we measure these applications or intelligent applications, where it's not a technical measurement, it's a business measurement, where I can say, with this solution, I can solve your problem at the rate of 50%, 60%, 80%. Then we can at least qualify the ROI on that.
I've been talking about security in the same context for a number of years, right? Because people don't care how many, widgets or something went on. They want it in business context, right? And I think that's getting those metrics, and they're different typically in every organization, but figuring out what those metrics are that we need to convey the success or failure. And I think that's a fair thing we should talk about in a second. Is important, especially in a business context. It doesn't mean you can't collect those other measurements for the application or for the tuning, but making sure that we're talking in a business context. And speaking of failure, that doesn't sound right. Talking about challenges related to this, Mike, what are some places from a computer vision perspective that, because, Amal just said Y is lower than X. It's not always lower than X sometimes.
What, you want an example of failure, or? Got plenty of those.
some. How about some example? If you got some reference points from the challenges where you thought this was going to work, but maybe it didn't.
Well, I have an example of something that I thought was really easy and turned out to be really hard. And
that's good.
It sounds like a really simple problem, actually. And I bet if there are data scientists listening in on this, they're probably thinking, that's a piece of cake, Mike. But it was a client, one of my favorite clients came to me and said, I want an application that can help my differently abled, cognitively disabled employees basically upskill, do things that they weren't otherwise qualified to do. In this case, he wanted them to be able to conduct cycle counts or counting inventory in their warehouse. And they have handheld devices, and he wanted them to point their cameras on these handheld devices at a pile of boxes and count how many boxes were in that image. And we were constrained. We could only look at this pile of boxes head on. Couldn't see the side. And he calls me up and describes this, and I'm thinking, well, a 5-year-old could count boxes, so I ought to be able to write an application that can do that. It turns out that that's actually really hard. And if you think you can count out there in the internet land, then you can't, I promise. Because you have to count things that you can't see. So you have to know context, first of all. You have to know that this is a pile of boxes. And that constrains you to be able to applying your application just in a warehouse with a pile of boxes. And you have to be able to count not only the boxes you can see, but the boxes that are obscured by the other boxes. And so that's not computer vision, right? And computer vision can only count things that it can see, or count things that are in an image. So that led to a lot of banging my head against the wall. But eventually we got to a point where we were able to achieve his criteria for a successful accuracy in our counting. But it was tough.
Hey, Mike, maybe there's a similar problem in retail, where they want to understand the inventory that's on the shelf, but like you said, computer vision can only count what it sees. Mm-hmm. But retail, adds a notch to it because of there's a mechanism when you pull something out, it pushes it forward, right? So from a camera's angle, it'll always be like, oh, I can see something there. unless it's empty, they're like, oh, it's empty. So it's always like you have something or you don't have anything. Like right. they don't, but they want to understand, do I have a few? Do I have 10? Or do I have, it's full, right? So it's an interesting problem. And I think if you solve it, maybe here's a new challenge.
Well, so now you're talking about video analytics as opposed to image analytics, where you have to constantly be analyzing a video stream so that you know what's happened and then you can predict what's going to happen, or at least you know the state that you're in currently. And that I think is a huge future direction for computer vision, is real-time or near real-time video analytics. Again, hugely computationally intensive application or applications that are going to be, we're going to need to do them on the edge. It's not going to make much sense to send a video stream over the wire and get the results that you need really quickly in that case.
So I think since we brought up the ethical stuff earlier, now we're talking video analytics, it's probably a good time to maybe talk about those ethical aspects or biases that potentially come out.
Sorry, we got to go. We're out of time.
And now we'll invite our HR rep on.
Yeah, there's machine learning bias everywhere, right? And no matter what, you can't avoid it. But you do need to understand it. And in video analytics, a big thing that's coming is video analytics of human-human interactions. How are people communicating with each other? And visually, you can think of this as when you have a conversation with somebody, probably the majority of the information that you're conveying is conveyed through your vocal intonations and your hand gestures, body language, not just the text that you're speaking. And when you start training models, if you train models on a segment of the population that's interacting in a certain way, that model isn't going to work on another segment of the population, or it's going to work poorly or inaccurately, and that can lead to big problems. It's coming. It's going to be big, and there are going to be a lot of challenges. And I don't have time to even discuss all of them today.
I think, Jason, it's the downstream actions that have bigger impact, right? So ethical biases in a model where we say, in certain cultures, a certain action means something, and you predict that, and you've trained it on that, right? And suddenly there's a change in that data where that same action might mean something else. But now, because you've put in this, actionable insight where it says, oh, if I see this, you should be doing this, right? And the human takes that action, not knowing that, well, the data has changed, the context has changed. See, Mike, I'm learning something from you. The context has changed, and so a different action has to be taken. So, Mike, a quick question on that: is it enough to have a wide variety of data, different conditions, to train the model on to cover for that bias?
Um, yeah, maybe an infinitely wide, yeah. No,
Oh, that's all you had to say.
well, think about it this way. Like, think about how many different ways humans interact with each other. We lie to each other. We're sarcastic. We joke. We cry. Think
Feel
about
called out.
watching a movie. How do you, you're to train a model to understand what another human is trying to convey through their facial expressions or hand gestures is, say, emotion specific in many cases, or information specific, the kind of information you're trying to convey. So it's I work with a lot of bright young data scientists, and if I were to give them advice, and I'm old now, so I get to give people advice, I'd say get into video analytics. It's this very there's a lot of job security there because it's so complex, and it's going to be very, very important in many different applications.
Love it. And actually, that leads to kind of our question that we kind of finish up with is, where do you think we're going? I think, you tagged the video analytics aspect. Anything else that we should be talking about from where we think? I was in a meeting yesterday where our CEO asked a thought leader, like, where do you see this in 10 years? And he had to think about that for a minute. And you don't have to go 10 years out, but what's the next big thing?
Well, as a data scientist, I definitely will not go 10 years out because I know that whatever I predict will be wrong. But I keep coming back to optimization. So video analytics combined with optimization. Both Andy and Amal mentioned several optimization cases. So how do you not only take what you know about the situation right now, how do you predict what's going to happen in the near future, and then how do you simulate other scenarios that allow you to make a better decision right now to achieve a better outcome in the near future? That's optimization. That's simulation and optimization combined with video analytics. You're going to need your big old NVIDIA box on the edge to do that. There's no stopping it. It's going to happen.
And I think Moore's Law, back to Andy's point, that generational, I've got different video cards in different systems from an NVIDIA perspective. It's amazing how many, the changes that are happening in each iteration of those things. And I know they probably got 4 already developed, that have yet to come out. What about you guys?
I think so Mike covered the use cases or where that technology is moving, right? From a computer vision, where those use cases are going to come through. I think in the near future, you'll see a lot more operationalization efficiencies come through in running these models. So there is infrastructure, right? And they're already making significant strides in providing that compute, that horsepower that's needed. We have, the data scientists who are innovating on building these models accurately, covering more use cases. Now, there is a middle tier of software that is required to operationalize that on this hardware. And that is where that efficiency is going to start coming in, is how do I take a massive model, run it efficiently on a machine based on the characteristics of the machine, right? So it might not be the case. I think we covered this a little bit in our last session on how we should be able to run the model based on what compute you have. So do you have just a CPU and an iGPU or a GPU or full-blown FPGA? What do you have? But if I have to go back to Mike again and say, hey, Mike, can you build something for an FPGA versus can you build this for that, right? That is going to be, right now, you don't have to do that, but there are still steps that need to happen if I want to run it on an FPGA. And I think that software layer is going to abstract that out, where more and more people will start adopting it easily. And I think that I have a feeling we're at the cusp of that, where we'll start to see a lot more of those frameworks come through, enabling a lot more people to start leveraging this, where we won't need super smart people to run this out, right? How do I run this? Like, oh, take this, put it together, start running it.
Well, I think, again, just to wrap up, I love, first of all, awesome conversation, guys. Really exciting. And I think we should probably do more of this. We'll figure that part out. But I think, to your point, Amal, and as I start thinking I've been thinking about that 10-year thing the whole time we've been talking. And what you just said kind of triggered something to think about is more people will have access to this. And I think that's, and I was thinking kind of like, I remember when I was younger, nobody had a computer in their house. We had to go somewhere. And now I've got, I don't even know how many. I don't tell my wife.
You have one in your pocket.
But yeah, exactly. And so the awesome thing about that is that made a whole bunch of accessibility to other things that we would have never had access to. And I think doing this very thing, and especially those abstraction layers that you're talking about, so that it opens it up regardless of what those devices are, to be able to have that platform to execute against, that's really exciting. That's some really cool stuff. And again, as the infrastructure, keeps on innovating and doing those things, I have nothing but, excitement for it. We'll be able to solve more complex problems and have more quality of life as we move forward.
Absolutely.
Well, guys, you guys rock. Good times. And for those of you out here listening and commenting and giving us information that you'd love to hear on other episodes, please keep doing that. We love you guys out there. If you want to know more about what we do here at Insight, make sure that you visit us at solutions.insight.com. And I hope you tune into our next Insight Live. Thanks, everybody. Thanks, guys.
Thank you.
Thank you.
Thanks,
I
Jason.
know.